First thing we do here is to simplify a bit, because we know that the root of -1 equals I. So we're going to replace that. So to make it a little bit easier, we can maybe see that this is the same thing as having 6 times -1 and 4 times -1. I'm showing the work so that people who haven't seen this before can really understand it. And so this is the same thing as root 6 times the root of -1. We can separate roots like this. Now let's see where we have the root of -1, which is equal to I. So we have it here, we can replace that, and we have it here. So in the next line, we have root 6I minus 2. Root 4 is 2. So we have 2 times 2 then gives us 4. And we have I times another I, which is I squared. All squared. So if we understand that the root of -1 equals I, it should make sense that -1 equals I squared. Right? When we square the root cancels. So -1 equals I squared. This is something else we should know. Okay, so this would equal -1, and we'd have -4 times -1 would give us +4. So we rewrite this, root 6I plus 4. So now we FOIL. So foiling, we get the first times the first plus the first times the last plus the insides plus the lasts. When we have root 6 times root 6, we know the roots cancel, so that gives us 6. And we have I times I is I squared. Writing this in proper form, we have 4 root 6I and another 4 root 6I, so we can combine those two, plus 16. So combining these two terms, we can treat the root 6I like a variable, like x. So we have 4x plus 4x would be 8x, so this would be 8 root 6I in the middle. So we have 6 times I squared, which is -1, plus 8 root 6I, like we said, plus 16. So that will evaluate to 10. And then plus our 8 root 6I. There's nothing we can simplify with root 6I. 6 doesn't have any perfect square factors. And the way this is written is correct form. You write the constant first and then the number with I at the end.